So in question 15, question says, in the figure shown below, at any instant, velocity of two different masses are given. Pulleys A and B are identical and can move freely. Velocity of mass m1 is v1 equal to 3 meter per second and velocity of mass m2 is v2 equal to 2 meter per second as shown. List 1 represents the speed of points mentioned and angular speed of pulleys, and list 2 contains the numericals in SI units. Mark the correct matching. So what we have been given is the velocity of m1 is 3 meter per second v1 and velocity of B block of mass m2 is 2 meter per second as shown. v2 is 2 meter per second as shown. So the options are about speeds of different points. The first is speed of point P on the string. We can use the constant relation here to find the speed of point P. Again, for finding the speed of point P, constant relation is, if tension in the string is T, then the equation is, on M1 there is 3T acting, so 3T into 3 plus 2T into V2, which is 2, minus T into velocity of point P is 0. This gives us Vp is equal to 13 meter per second. So that means P matches with 5. Let's look at Q now. Speed of point Q of the string, and speed of point R is straightforward because the distance between point R and block M1 is fixed. So point R has same speed as the block, and that means speed of point R is equal to 3 meter per second. We can keep Q right now, but we can fill for R, and speed of point R is 3 meter per second, so R matches with 4. And speed of pulley B is, well, pulley B is same as speed of M2, which is 2 meter per second, so that means S corresponds to 2. Now question arises, well, based on this we can of course get our answer, because P is 5 and R is 4, S is 2, so this only B can match. But let us still find the speed of point Q. We can see here that speed of Q with respect to pulley B will be equal to speed of R with respect to pulley B. Okay, that means VQ minus VB is equal to VR plus VB. VR plus VB is 5, and so VQ is equal to 7 meter per second, and that means Q matches with 3. So B is the correct answer for question 15. Let's go to the next question now. A balloon starts rising from surface of the earth. The ascension rate is constant and equal to V0 equal to 3 meter per second. Due to wind, the balloon gathers a horizontal velocity component Vx equal to y, where y is the height of ascent. List 1 represents the various quantities related to the motion of the balloon, and list 2 represents their numerical value. Mark the correct matching. All values are in SI units. So the first information is about horizontal drift of the balloon at height y equal to 4 meter. So we have to find the drift of the balloon when the height y is 4 meter. So dy by dt is constant, that is 3 meter per second. So we can say y is equal to V0 into t, or simply 3t. Now Vx is dx by dt. So dx by dt is y, that means V0 t, and which gives us drift x is equal to V0 t square by 2. Now when y is equal to 4 meter, then t is equal to 4 by 3 second, and so drift x will be equal to V0, which is 3, and 2 is 2, and this is t square becomes 16 by 9. So this is equal to 8 by 3 meter. So it means P matches with 3. Let's look at Q. Speed of the particle at height y equal to 4 meter. At y equal to 4 meter, of course dy by dt is fixed. We have to find dx by dt. So the Vx is V0, which is 3, and t is 4 by 3. 3 into 4 by 3 is 4 meter per second. Vy is fixed and it's 3 meter per second. So V at that height will be under root Vx square plus Vy square, which is 5 meter per second. So Q matches with 4. So Q matches with 4. Let's look at R now. Tangential acceleration of the balloon at y equal to 3 meter. Let's get the expression for acceleration. Ay we know is 0 because Vy is constant, it's 3 meter per second. So to get A will be same as Ax, and Ax is numerically equal to V0 or 3 meter per second square. Now the question is, what is tangential acceleration at y equal to 3 meter? At y equal to 3 meter we have Vx. If we put y equal to 3, then t is equal to 1 second. So both Vx and Vy at y equal to 3 meter per second. So if I draw Vx, Vy, and then acceleration is in this direction only, a, which is again 3 meter per second square. So what is tangential acceleration? The component of acceleration parallel to velocity. So this angle will be 45 degree, the angle the resultant velocity makes. So tangential acceleration is a cos 45 degree. That means tangential acceleration is 3 by root 2 meter per second square, which means R matches with 1, and the normal acceleration will be again sine 45 degree, which is same as 3 by root 2. So S also matches with 1. So if you look at the options, A matches exactly with what we have got. So A is the answer for question 16. Let's go to the next question now. Question 17 says, block A is on a frictionless horizontal table. A massless and inextensible string fixed at one end passes over a smooth nail fixed with the block A. The other end is connected to block B of mass 2m as shown in figure. Initially the block B is held at rest and the angle the thread makes with vertical is theta equal to 30 degree. At t equal to 0, blocks are released to move by their own, then match the corresponding list. All values are in their respective SI units. Take m equal to 1 kg, g equal to 10 meter per second square. Initial acceleration of mass A. Let's look at free body diagram. It's clear this is the direction of AA initially, and this is the direction of AB initially. The constant relation is that AB is equal to AA by 2. Now if we write equation for block A, we get MAA is equal to, this angle is 60 degree, so T cos 60 degree or T by 2. For the block we have 2 mg minus T is equal to 2 MAB, and AB is AA by 2. So if we combine these two equations, what do we get? We get T is equal to 2 MAA, and it's also equal to 2 mg minus MAA. This means 3AA is 2g, or AA equals 20 by 3 meter per second square, which means P matches with 2, and initial acceleration of B is half of this, so that means B is matching with 3, Q is matching with 3. Tension in the string at T equal to 0, that we can find now because tension initially is 2 times MAA. So M is 1 kg, 2 into 1, and AA is 20 by 3. So this is 40 by 3 Newton. So R matches with 1, and normal force by the table on A at t equal to 0. For this we have to look at FBD of A, and there is this mg, that means 10 Newton. There is tension T, which is 40 by 3 Newton. There is also this tension here, again 40 by 3 Newton tension, and there is this normal reaction. So normal reaction is equal to 10 plus 40 by 3 minus vertical component of 40 by 3 into root 3 by 2. How much is this? This is 70 minus 20 root 3 by 3. So that means S matches with 4. If you look at the options, B matches with what we have got. So answer to question 17 is B. Let's now go to the final question, the last and the final question of this test, question number 18. Question says a wedge with an inclination theta equal to 37 degree can rotate in horizontal plane about a fixed vertical axis AA dash. A small mass M placed on the rough inclined surface of the wedge rotates with the wedge itself at a radius r equal to 2 meter about the same vertical axis AA dash as shown in figure. Coefficient of friction between inclined surface of wedge and mass M is mu equal to 0.4. Use G equal to 10 meter per second square. List 1 represents the values range of angular speed omega, and list 2 represents the direction of frictional force and response of mass M. Mark the correct matching. In list 1, entropy is omega is 1 by 2 radian per second, Q is omega is 3 by 2 radian per second, and so on. In list 2 we have basically to determine if the friction is acting, what's the direction of friction, and if the block is moving, which way it is going to move. Now to solve this question, we find 3 different values of omega. We find omega 1, which is the angular velocity if there was no friction acting, right? Similarly, we'll also find omega max with friction. What is the maximum value of omega for which the block will not slide? And also what is the minimum value of omega for which the block will not slide. So we are going to find these 3 values of omega. So first of all, we find the value of omega for which the block will move in the circle even without friction acting. Now in that case, FBD will look like this. There is mg, there is n, and this is the direction of acceleration. So our equation will be, now this angle is theta, 37 degree. This angle is also theta, and this angle is also theta. So we have n cos theta equal to mg, and n sin theta equals m omega 1 square r. Solving, we get tan theta is equal to omega 1 square r by g. If we put this value, omega 1 comes out to be equal to under root of g tan theta by r. Putting all the values, this omega 1 comes out to be about 1.94 radian per second. Let us look at now omega minimum. For omega minimum, the free body diagram will look like this. There will be mg, and of course there is n. For omega minimum, friction is going to act up the incline, and of course this is omega. Let's call it omega 2. That's omega minimum, right? Now the equations will be, and the acceleration is omega 2 square into r in this direction. So we resolve everything horizontally and vertically. So horizontally we get n sin theta minus mu n cos theta is equal to m omega 2 square r, and vertically we'll get n cos theta plus mu sin theta equal to mg. So by dividing the two equations, you get omega 2 square r by g equals sin theta minus mu cos theta upon cos theta plus mu sin theta. And if we solve for omega 2, we find its value comes out to about 1.16 radian per second. Similarly, we also find omega 3, the maximum value of omega. Okay, and in that case, for the maximum value of omega, the friction mu n will be acting down the incline because the tendency is to slip up the incline. And the equations will change by putting the friction down the incline, and again writing equation same way, you will find omega 3 value is about 2.87 radian per second. Now we are armed with these three values of omega, we can easily judge. Let's look at P now. It says omega is 1/2 radian per second. So this is well below this value. So that means the block will slide downward and the force of friction will be acting up the incline, which means for P, the item which matches is 2 and 4. Now for Q, when omega is 3/2 radian per second, in this case it is greater than the omega minimum required, so it will not slide. Friction will be acting up the incline, which means Q should match with 3, 4. Friction will be acting upward. Then let's look at R. Here the value is 5/2 radian per second, which is much greater than this but less than omega 3. That means tendency to slip was up the incline but will not slip, it will remain stationary and friction will be acting downward. So that means it will match with 3 and 5. And finally for S, when omega is quite high, it will actually slip. So it will not remain stationary, it will slip upward. So it will match with 1 and the friction will be acting downward. So it will match with 1, 5. Let's look at the options. Among the given options, C is matching exactly as per our working. So C is the correct answer for this question. Well students, with that we come to the close of this quick solutions. Hope this solution has been helpful to you. I wish you all the very best for your preparations.